Greetings and welcome to Lecture 4.3, Multiplication with Decimals. So I'm going to give you a problem to think about first, just mull it over. So let's say there is a half-off sale, and usually Levi 501 jeans sell for $46.80 and now are priced at $23.40. Well, therefore, if you can think about it, half of 46.80 is 23.40. In 1/2 can be written as 0.5 and the of can be translated into multiplication. So we have 0.5 times 46.80 is 2340. Now let's just ignore the decimals for now. Just ignore them and let's do the regular math. So 4,680 times 5 is 23,400. That looks a lot like 23.40. So multiplication with decimals is very similar to multiplication with whole numbers. Just looks like we have to do a little changing, a little manipulation. Now let's take an example. 0.5 times 0.3. Let's do one where we convert it into a fraction because we know how to work with fractions now. So let's convert it into a fraction and then do our regular multiplication of fractions. So 0.5 is 5/10. 0.3 is 3/10. 5/10 times 3/10 is 15/100. And then if I convert it back in, 0.15. 0.15 has 2 digits to the right of the decimal. 2 digits, right? So let's try it again using that same method by converting over to a fraction and multiplying again. 0.05 and 0.003. So convert them both over into a fraction. 0.05 is 5/100. 0.003 is 3/1000. Multiply straight across. 5 times 3 is 15. 100 times 1,000 is 100,000. In other words, I have 5 zeros here. I have 5 spots here. Here I had 2, and I have 2 zeros. Here I have 3 decimals to the right. I have 3 zeros. I have 5 decimals to the right. I have 5 zeros in the denominator. I better have 5 decimals to the right. So let's do it again with different numbers. So first I have 2.1 and 0.07. Let's convert 2.1 to a mixed number and then to an improper fraction, and 0.07 to a fraction, 7/100. Multiply across. I have 147 over 1,000, which is 0.147. Again, three zeros, 3 decimals. Now, I know we ran through that kind of quick, but think about what's happening. 2.1 and 0.7. Well, 0.1, there's 1 decimal place to the right, and 0.07, there's 2 decimal places to the right, and our answer had 3 decimal places to the right. Let's go back. 0.5 and 0.003. 0.05 has 2 decimal places to the right. Now let's think about the way that it's working. So 0.5 times 0.3 is 0.15. The result has 2 digits to the right of the decimal. 0.05 times 0.003. The answer is 0.00015. The result has 5 digits to the right of the decimal. 2.1 times 0.07. The answer is 0.147, which has 3 decimal places to the right. But what do each digit have? 0.5 has 1 digit to the right, of the decimal, and 0.3 has 1 digit right to the decimal. 1 plus 1 is 2. The result has 2 decimal places to the right. 0.05 has 2 digits, and 0.003 has 3 digits. 2 plus 3 is 5. The result has 5 digits to the right of the decimal. 2.1 has 1 digit, and 0.7 has 2 digits. 1 plus 2, 3, and the result has 3 decimal places to the right. So using what we know, how many digits to the right will the solution have of 2.987 times 24.82? 2.987 has 3 digits, and 24.82 has 2 digits to the right. Therefore, 3 plus 2 is 5. So our solution should have 5 decimal places to the right. So here's method 2. So the first method was converting it over into a fraction and then working our way through. The second method is doing our multiplication just like we normally would. So 5 times 6 is 30, carry the 3. 5 times 3 is 15, plus 3 is 18, and so on. And work through your problem like you normally would. Okay, so our final answer to, in essence, 436 times 305 is going to be 132,980. Now, count the number of decimal places to the right of the original problem. 1, 2, 3, 4. There are 4 decimal places to the right of the original problem. Now, we're going to move the decimal in the solution that we found with the whole numbers 4 to the right. 1, 4 to the left. 1, 2, 3, 4. And end between the 13 and the 2. So our final result should be 13.2980 or 13.298, because we don't necessarily need that 0 hanging off the end. Let's take an example with negative numbers. Negative 8.9, negative 0.2. Now our final solution should have 1, 2 decimal places to the right. But let's keep going. Well, first and foremost, a negative times a negative, our ultimate solution is going to be positive. 8.9 times 0.2 is going to be 178. But now I have to deal with the decimal. So remember, I've got to move it 2 to the left because I originally had 2 to the right. Here's my decimal, 1, 2. So my final solution is going to be 1.78. And yes, that's 2 decimal places to the right, ultimately. Try another problem. 7.0001 times 3.04. Now I know my final solution is going to have 1, 2, 3, 4, 5, 6 decimal places to the right. So I'm going to go ahead and work out this problem like you normally would. 4 times 1 is 4. Then I have 0, 0, 0, 7, 0, 0, 0. 4 times 7 is 28. Now I have a full row of zeros because 0 times anything is 0. 3 times 1, and that's my holding place there, is 3. 3 times 0, 0, 0. And then 3 times 7, 21. 4, 0, 3, 0, 2. Oop, that was an 8. 2, 1, and still adding 1. So I have 2, 1, 2, 8, 0, 3, 0, 4. That's just the regular multiplication, but now I have to move the decimal. How many spots? 1, 2, 3, 4, 5, 6. 6 spots. 1, 2, 3, 4, 5, 6. So my final answer is 21.280304. And so let's take a problem and estimate what the answer is going to be close to. Here's a problem, 3.05 times 4.36. Well, if I round 3 to the nearest whole number, or pardon, 3.05 to the nearest whole number, I get 3. And if I round 4.36 to the nearest whole number, it's going to be 4. And 3 times 4 is 12, so 3.05 times 4.36 should be close to 12. So let's estimate what each of these problems are close to. So 29.4 times 8.2. 68.5 times 172. And 2.32 squared. So let's just take these one at a time. Well, 29.4 is really close to 30. I know normally we would round up, but I'm just estimating, I'm not rounding. So 29.4 is very close to 30, and 8.2 is close to 8. So 30 times 8 is 240. 68.5 is really close to 70. 172 is close to 170, and if I multiply those two together, I get 11,900. And then 6.32 squared, well, that's really, 6.32 is really close to 6, and 6 squared is 36. What are the true solutions? So if I got 240 by estimating, the true solution is 241.08. That's pretty close. I estimated as 11,900. The real solution is 11,782. And I estimated at 36, and my real solution is 39.9424. Just like whole numbers, when we combine different types of operation with decimals, we do need to remember our order of operation. For example, 0.05 times the quantity 4.2 plus 0.03. We're going to do the parenthesis first, so our addition. 4.2 plus 0.03 is 4.23. Now we're going to multiply 0.05 times 4.23. I'm going to do the regular multiplication. 5 times 430 is 2115, but then 1, 2, 3, 4, I had 4 decimal places. I'm going to move my decimal 4 places to the right, so my final solution is 0.2115. Now I want you to take a look at this example, and if you need to, pause the video, but we're going to work through it the same way we normally would. Exponents, then multiplication, and at each stage we're going to move our decimal if needed to get our final solution. So I'll let you work through that on your own. Let's take this problem that puts everything kind of together that we've been doing. Sally earns $8.32 for each of the first 36 hours she works in 1 week, and $12.48 in overtime pay for any additional hours she works that same week. So how much money will she earn if she works 42 hours in 1 week? Well, we do know 42 minus the 36 is 6. Those are the hours she has worked overtime. So now I just multiply 832 times the 36 plus the 1248 times the 6. The 8.32 times 36 is our regular pay. The 12.48 times 6 is the overtime pay. Add them together, and the final result is 374.40. So that's it for this video. Until next time, be seeing you.